Here you are going to learn the question number 5 which is given in the exercise in chapter 8 heat and thermodynamics. The question is explain calorimetry and derive an expression for final temperature when the two thermodynamic systems are mixed. First we learn about what is calorimetry. Calorimetry means the measurement of amount of heat released or absorbed by the thermodynamical system during the heating process. When a body at higher temperature is brought in contact with another body at lower temperature, the heat lost by the hot body is equal to the heat gained by the cold body. This is called as calorimetry. Here, when the heat is lost by the hot body and when the heat is gained by the cold body, the main important condition is no heat is allowed to escape to the surroundings. The principle of calorimetry that can be mathematically expressed as the quantity of heat gained by the cold body is equal to the quantity of heat lost by the hot body. Here negative sign shows that heat is lost by the hot body. On the whole, minus Q lost, if it is brought in this side, LHS side, now the new equation, that one becomes Q gained plus Q lost is equal to 0. To perform the experiment in calorimetry, we need to use the device called calorimeter. Heat gained or lost is measured with the calorimeter. Usually the calorimeter is an insulated container of water as shown in the figure. Within the calorimeter there is a copper vessel. The 2/3 of the copper vessel to be filled up with water. There is a stirrer. With the help of stirrer we are able to stir the water after mixing the sample. There is one more provision is given to measure the temperature of the mixture. There is a hole at the top of the lid. Here through the hole one thermometer can be inserted. The copper vessel, stirrer, thermometer, everything is surrounded by the insulating material like wood or wool. Using calorimetry concept and also with the help of calorimeter, we are able to measure the heat lost by the hot body or heat gained by the cold body. Not only that, the final temperature of the mixture can also be found out. Here I have taken one sample. That sample object that is to be heated. After heating, the temperature of the hot substance sample to be measured with the help of thermometer. Its temperature is measured as T1 degree Celsius. Within the calorimeter, water is filled up. That water at ordinary room temperature, now the thermometer to be inserted within the calorimeter. With the help of the thermometer, we are able to measure the temperature of the water which is filled up within the calorimeter. That copper calorimeter that is surrounded by wooden vessel, wooden container. So it is fully insulated. No heat is lost to the surrounding, no heat is gained from the surrounding. So in this condition, two temperatures are measured. One is T1 degree Celsius, that is the temperature of the sample. T2 degree Celsius is the temperature of water. Now this sample, that hot substance, that is to be kept within the water, that is to be dropped within the water. By opening the lid, this sample to be dropped within the water. After dropping, this sample will be within the water. Are you clear? After dropping, the sample will be within the water. Now what will happen? This sample will act as the hot substance and the water will act as the cold substance. So the hot substance, that one will exchange the heat to the cold substance. So the hot substance, it loses the heat. The cold substance, it gains the heat. So heat is lost by the hot body and heat is gained by the cold body. So after some more time, what will happen? No, that one will act as a mixture. This is called mixture. The mixture of cold body and hot body, both are called as mixture. Now after some time, both the sample means this one, both the sample and water reach a final equilibrium temperature. They will reach a final equilibrium temperature. Now the thermometer reading will be slightly rising. So after rising certain temperature, the new temperature can be called as, what is this? The final temperature, equilibrium temperature can be called as TF degree Celsius. Are you clear? So here heat is lost by the hot body and heat is gained by the cold body. Finally, the both sample as well as water, both of them will reach the final temperature. Now our next step is to derive the expression for final temperature of the which one? Sample and water. How to start with? Here that heat lost by the hot body is equal to heat gained by the cold body. So that is a basic principle of the calorimetry. So how to write this? Heat gained by cold body will be equal to heat lost by the hot body. So this is the basic principle of which one? Calorimetry. So which one is the cold body? Water is the cold body. The water's mass is m2 and its respective specific heat capacity is s2. How to get the formula to find out heat gain? What is the basic formula? m2, that is nothing but mass of the water. m2 is the nothing but mass of water. Specific heat capacity of water is s2. Difference in temperature. How to find out the difference in temperature? Initial temperature of water is T2, final temperature of water is Tf. Therefore, Tf minus T2 must be written. Are you clear? And then now we have to use the sign convention because heat is lost by the hot body, therefore negative symbol must be used. Hot body is nothing but that sample. How to write the formula? m1, mass of the sample, specific heat capacity of the sample, and difference in temperature. How to find out the difference in temperature? Initial temperature of the sample is T1 degree Celsius, final temperature of the sample is Tf degree Celsius. Therefore, difference in temperature is Tf minus T1, that is nothing but difference in temperature. So this portion that gives you the heat gained by the cold body, this portion that gives you heat lost by the hot body. Okay, our aim is to get the formula for Tf. So now multiply inside m2 s2 Tf minus m2 s2 T2 is equal to minus m1 s1 Tf. Bring this negative sign inside, that one becomes plus m1 s1 T1. Bring this Tf factors in one side. Already m2 s2 Tf is here. Bring the factor here, that one becomes m1 s1 Tf. And here already m1 s1 T1 is already here. Bring this factor on the other side, that one becomes plus m2 s2 T2, that one becomes in this form. Now Tf can be taken as a common factor. So m1 s1 plus m2 s2 is equal to m1 s1 T1 plus m2 s2 T2. Our aim is to get the expression for Tf. So Tf is equal to, write the same expression, m1 s1 T1 plus m2 s2 T2 whole divided by, bring this bracket factor here, m1 s1 plus m2 s2. So this is the final temperature, equilibrium temperature. So clear, after mixing both, so clear that thermometer reading will be attaining a equilibrium temperature, no final temperature. That final equilibrium temperature of both the two objects, sample as well as water, that could be measured by using which phenomena? Calorimetry phenomena. With the help of calorimetry, with the help of calorimeter, we are able to measure the final equilibrium temperature of both the two objects, that is mixture. Okay, very simple one, may be asked in the exam. Okay, thank you.